Greetings to CMP 1001 Introduction to Programming with C++ video series. In this video, we will look into the conditional statements in C++, namely the if statement as well as the switch statement. So far, in all C++ programs we have written, the program executes all the statements included in the program in a sequential manner. He starts from the first statement, and then he executes the second, the third, the fourth, all the way down to the last statement in the program, one by one, without any condition. But what if we want to execute some portion of the code based on a particular condition? In these kind of scenarios, you have to utilize a conditional statement in C++. The language provides us with mainly two conditional statements, the if and the switch. Let's first look at the if statement, the one that are being used more than the other one. When you want to use the if statement, you simply write down if, you open up a parenthesis, you write down the comparisons, and then you open up a curly bracket, you write down whatever statements that you want to be executed if the comparisons output is true, and finally you close down the curly bracket. So now, if the comparisons value is going to be correct, these statements will be executed. On the other hand, if the comparisons value is turned out to be false, then these statements will not be executed and will simply be skipped by the program. Speaking of the comparisons, we have comparison operators in C++. If you remember from our operators part, we have a group of operators called the comparison operators. And we can use them inside the if statements. A simple example is going to be something like this. Let's assume that we have an integer called x_position, and I want to check if the value of the x position is greater than 0. This operator will simply compare these two values, and if the x_position's value turns out to be greater than 0, the output of this operator is going to be true. Otherwise, the output of the operator will turn out to be false. Okay, let's look at this example, a very simplistic example on using the if statement. So write a program which reads the grade of a student. Then, if the grade of the student is greater than or equal to 60, the program should print out you passed. On the other hand, if the grade is lower than 60, we don't want the program to do anything. The program shouldn't do anything at all. So I declare a variable, let's call it grade, and then I read a value inside this variable, grade, from the user. Then I'm going to say if grade's value is going to be greater than or equal to 60, I open up the curly bracket, and within this if statement, I will be writing down std code, you have passed. Let me run this code now and try to give him a couple of different values. First of all, let's give him something big, something greater than or equal to 60. Let's say 78. The program is now telling me you have passed. Because now, when he goes to line number 9, he will check the value of grade variable. It is now 78. 78 greater than or equal to 60, it is true. So the comparison's output of the if is true. It means it will be executing this line within the if clause. Let me try it with some grade value which is less than 60. Let's say 54. Now, as you can see, the program didn't tell us anything. Because now, after reading the variable at line number 7, he also is going to also check this comparison. 54 greater than or equal to 60, false. So this part, the comparison's output is false. So C++ will simply skip all the commands, all the statements within the if clause. All of them. You can write down as many as you want. One thing of importance is the fact that unlike the other statements that we have seen so far, you should not put a semicolon at the end of an if statement. This is a super common mistake. The thing is, technically C++ allows you to put a semicolon at the end of an if statement. However, if you do this, if you put a semicolon here after the if, this part of the code will become practically outside of the if statement. So let me show it with the same example. where I give the grades value as 54. Because the output of this program will now be different. Here, as you can see, the program is telling me you have passed. So this std code line number 12, is being executed regardless of the output of the comparison. Why? Because of this little semicolon, we tell to C++ that this if statement ends here at the end of line number 9. The rest, this part, is actually outside of the if statement. So it will be executed no matter what the output of this comparison. There are mainly 6 comparison operators available for us to be used in C++. The less than, greater than, less than or equals, greater than or equals, and not equal. Please be careful not to confuse the assignment operator with the equals comparison operator. If you only use the equal sign once, it means the assignment operator. Whereas if you want to use the equals comparison operator, you have to write down the equal sign twice, one next to each other. So again, I would like to underline this fact because let's say we just want to say something like this: grade equals 60. And obviously I have to delete this and make it a correct one. Now this is a code which just says you have passed if the grade's value is exactly 60, which is a valid code, albeit you might think that this is not a very useful program. But it does work, and it will only say you have passed on a single occasion. 60, you have passed. The thing is, if I delete one of these equal signs, again the C++ will not tell me that this is a mistake. However, now if I run the code and I give it any value other than 60, it's gonna still say that you have passed. Note that now I'm using the assignment operator, so I am not checking if the value of grade is 60 or not. I am simply putting the 60 inside the variable grade. So you might be thinking like, what is being compared? What is being checked? C++ is trying to put the value 60 inside the variable grade, and if he is able to do that, if he can successfully put 60 value inside grade, it's gonna be true. If he's for some reason, due to memory management, operating system failure, whatever, if he's unable to put the 60 value inside grade, the outcome of this operation is gonna be false. So most likely it's gonna be true. So this is simply something like this now. If you simply use an equal sign so that you are referring to the assignment operator instead of the equal comparison operator, this is more or less similar to writing down true within the if clause, which means this part will be executed no matter what. Now suppose that we also want to inform the student if he or she has failed. If the grade is less than 60, we also want to tell to the student that you have failed. In those kind of scenarios, we use the optional else clause of the if clause. The else clause goes after the if clause. So at the end of the curly bracket of the if, you simply write down else. You don't write down anything next to it. You simply open up a curly bracket, write down whatever you want to be done if the comparison's value is false, and then you simply put a closing curly bracket. Okay, let's modify our previous program so that the program will say you have passed if the grade is greater than or equal to 60, and if the grade is lower than 60, the program should say you failed. Okay, so the grade is greater than or equal to 60, you have passed. Then afterwards, I'm gonna say else std code you have failed. Maybe, oh, why I'm happy? I shouldn't be happy. It's not a good news. Here, when I say 98, you have passed. But if I tell him something lower than 60, 34, the program is now telling me you have failed. So here, the program has two branches of execution, it is called. Based on the value of the grade, the program will either execute this part of the if or this part of the if. which is inside the else clause. So these two lines, both of them will never be executed at the same time. Either the first one or the other one will be executed. Alright, now let's continue with a more sophisticated looking example. Write a program that calculates the points of a student in a test. The test has 50 math questions and 50 history questions. And the program will have 3 inputs. The correct math answer count, which is gonna be obviously an integer value, and let's call it correct math count. Next, the correct history answer count, which is gonna be an integer variable, and it's gonna be called correct hist count. And finally, the class of the student. Most likely it's gonna be the string, and the variable's name is supposed to be stu class, short for student class. If he or she is a math student, each correct math answer will be giving him or her 1 point, while each correct history answer will give him or her half points. On the other way, if the student is a history student, then each correct math answer will give half, and each correct history answer will going to give him or her a single point. Finally, the program should calculate the point of the student and print it out. One final note, if the class is given anything else, anything other than math or history, the program should print out incorrect class. Alright, let us first declare our variables, which are gonna be int correct math count, int correct hist count, string stu class, and let us read the values inside these variables. Somehow, somewhere, I have to calculate the points of the student, so I will be requiring another variable. Let me call it int points. After reading these 3 variables, these 3 inputs, I'm gonna say if stu class equals math. If the class of the student is math with capital M-A-T-H, then the point calculation should go like this. 1 times correct math count plus 0.5 times correct hist count. So since I'm dealing with half points, apparently the points variable, it's supposed to be a double, not an integer. Now I have an else clause. What if the student's class is not math? Then I simply have 2 cases. The student class can be history, or student class can be some other thing that I don't care. Then, therefore, I need a second if clause. But this second if clause is gonna be inside the else clause, because I will only be testing the second if clause if the student's class is not math. So I'm gonna say if stu class equals history, then points equals 0.5 times correct math count plus 1 times correct hist count. Else, which means that the student class value is neither math nor history. So the program is supposed to say incorrect class. So apparently I have to write some more std code lines here just to show the output of the points. The total points from this exam is and this line will be repeated in here too. Let me run the code. So I will have 3 paths of execution here. If the student class is math, first path. If the student class is history, second path or second branch. If the student class is some other thing, third branch. So let's try the first branch. So I'm gonna say 40, 23, and math. So total points from this exam is 51.5. So 40 plus 23 divided by 2, because this is a math student. So 40 plus 11.5, it's gonna be 51.5. Let's try the second branch of execution. So it's going to be, let's say 30, 20, history. Here it's going to be 15 because this is a history student, so he's only getting half points for each correct math problem. So 30 divided by 2, 15, 15 plus 20, 35. And finally, the third branch, I'm gonna give him some numbers which I don't care. Let's say the student has correctly solved all the questions. However, he or she is a physics student, so I'm not gonna give him or her any points because no physics student should be taking this particular exam. So we now have 3 paths, 3 branches of execution, it is called. And as you can see here, you can put an if-else within an else clause, or you can put an if and else clause within an if. And you can put as many ifs elses inside ifs as you like, based on what you are trying to do. Inside an if statement, there can also be multiple comparisons. Because so far, we have mentioned that you can put a comparison. You are supposed to put a comparison. But what if you have to combine multiple comparisons? In order to do that, we have to combine these comparisons with either logical AND operator or the logical OR operator. These operators are depicted with 2 ampersand characters representing the logical AND operator and 2 pipe characters representing the logical OR operator. The behavior of this AND and OR follows the logic in math, the logic topic in math. So a simple example can go like this. Let's assume we have 2 integers a and b. So if a is greater than or equal to b and a equals 0. So in order to go inside this if clause, in order to execute the statements given inside this if clause, the a's value should be 0 and the b's value should either be 0 or a negative value. Because if the b's value is a positive value, then the left comparison will always be false. So false and whatever is gonna be false, so the statements inside the if clause will simply be skipped. Let's look at a more sophisticated looking program which we will be using the multiple comparisons. Write a program which reads 3 integers from the user. Then the program should calculate and print out the average as a double value, the maximum number among these 3, the minimum number among these 3, and the median number among these 3. The median refers to the one in the middle, the one which is not the maximum, not the minimum. So I will have 3 numbers. Let's call them number A, number B, and number C. I will have the double average, maximum, minimum, and finally the median. As always, I will start by reading values to these variables. As for the average, I can simply add these 3 numbers up and then divide them by 3. So average equals number A plus number B plus number C. And I can simply divide them by 3. But be careful, if you simply write down 3, then it's gonna be an integer division. If you want the division to be a real division, you have to either divide it by 3.0 or you have to use a casting operator to double or float to either the left hand side or the right hand side of the division operator. Then I can start my if statements. So since we are comparing 3 numbers against each other, there are basically 6 cases. 3 factorial, 6 cases. So one way of writing this thing, one way of answering this question is, well, simply check all the possible conditions. The first condition is where number A is greater than number B and number B is greater than or equal to number C. In this scenario, the maximum is gonna be obviously number A and the minimum is gonna be number C. The else clause just covers the rest of the 5 cases. So inside the else clause, I have to write down a second if. checking if number is greater than or equal to number C and number C is greater than or equal to number B. In this occasion, maximum is again number A, but then the minimum is number B. The else clause of this one, the second if condition, is now covering 4 conditions. So all I have to do right now is just continue like this and check the other conditions where number B is the greater, number C is the minimum, number B is the greater, number A is the minimum, and other cases where number C is the biggest. So let me finish these things. Alright, now I've finished all the cases. Note that I don't have actually 6 ifs, but I have 5 ifs, because the else of the last if actually covers the 6th case, where the number C is the biggest and number A is the smallest. I don't need to do any other checking here. So when you're dealing with these kind of a little bit more complicated looking conditional statement based algorithms, so you have to be careful. Do you really need these ifs, or you can just continue with the else clause and so on and so forth. Another thing that is important in this solution is the fact that we just simply do not calculate the median, which one of these numbers is the median. We already know which one is the maximum and which one is the minimum. However, we have no idea which one of these numbers is the median. So after the if cases, all of them are finished, I can simply find the median by adding these numbers all together and subtracting the maximum as well as the minimum. Now the maximum is one of these numbers, so it will cancel out one of these numbers on the left hand side. Similarly, the minimum is gonna be one of the 2 remaining numbers. So whichever is neither the maximum nor the minimum will be the median. Therefore, such a formulation will hold. Finally, I have added a couple of code lines just to print these values to the screen. So let's run this program with a couple of examples. So 5, 6, 7, a very simple example. Maximum is 7, median is 6, the minimum is again 5, average is again 6. Something where the order is a little bit weird. Maximum is 89, median is 12, and the minimum is 3. So this is a bit of a more complicated question, I can say, a complicated example, where we can utilize the multiple comparisons here. Note that this is one of the potential solutions to this problem. There are other solutions, some of which have the same number of if clauses, some of which have lesser number of if clauses. So let's try to solve the same problem with fewer number of if clauses than this one. So I will do a little bit of a math trickery here. So I will start by simply checking if number A is greater than or equal to number B or not. If that is the case, I will just say that the maximum among these 2 numbers is simply number A, and the minimum is gonna be number B. Else, simply the reverse. Number A is gonna be the minimum, number B is gonna be the maximum. Now I know that which one of these 2 numbers is the bigger and which one of these numbers is the smaller one. I will simply check the number C compared to the maximum of these 2 by saying number C is greater than or equal to, or simply greater than maximum. Because if that is the case, now it is for sure that it is going to be bigger than the minimum, because we already compared the 2 numbers among themselves. So in this case, I will simply say maximum is going to be number C. Else, if the number C is not bigger than the maximum, then I have to check if number C is less than the minimum. In that case, the minimum is gonna be number C. Whereas if neither one of these if clauses, these 2 if clauses, is correct, this means the number C is between number A or number B, whichever is the maximum, whichever is the minimum, we don't care. But we are sure that number C is between these 2 numbers, so we don't need to do anything else. Compared to the first solution, this is a bit of a shorter solution in terms of line of codes. However, algorithmically, it looks a little bit more complicated You have to think a little bit more to just get what kind of relationships that we have to utilize to decrease the number of if statements here. Note that when we are talking about multiple comparisons, a line like if A greater than B greater than C may seem reasonable and intuitive. However, this is actually very, very wrong. Instead of A greater than B greater than C within an if clause, you have to combine them like A greater than B and B greater than C. What is the problem in the first one? Let's look at our first solution to the previous problem and try to understand here. So let's try to rewrite this if clause with this A greater than B greater than C method. So all I have to do is basically deleting this part. So now, again, as you can see, C++ is not giving me a mistake. But the thing is, when you have such an if clause, what he will be doing is he will simply compare the values of number A versus number B. At the end of this comparison operator, the outcome will either be 1, representing true, or 0, representing false. Let's say this is true, so I will simply write 1 here, which is gonna be what the C++ will do. So then, as you can see, the next comparison is gonna be comparing 1 with the value of number C. So it's not gonna be a comparison between any one of these numbers. It is gonna be a comparison between the outcome, the logical outcome of the first comparison with the second number. And as you might imagine, this is gonna be completely wrong, nothing like what we have intended in the first place. One more note is that writing a single ampersand instead of double ampersand is a very common mistake when thinking about multiple comparisons. Similarly, instead of writing down double pipe, writing down a simple pipe operator is again a very common mistake. Single ampersand and single pipe characters are different type of operators that we will see in the upcoming lectures. As in the regular mathematical logic, we also have a logical not operator in C++, depicted by the exclamation mark character. What this operator does is it simply reverses the outcome of any other comparison that it is in front of. So if you have something like if not x equal 3, it just says if the outcome of this x equal 3 is true, it's gonna reverse it, so it will make it false. If the outcome of this comparison x equal 3 is false, then he will make it in the reverse and the outcome will be true. When using this not operator though, you have to be very careful about putting the parentheses. Otherwise, an exclamation mark in front of a variable will be actually a completely different operator, which again we will be seeing in the upcoming lectures. When dealing with multiple if-else structures within the same program, within the same context, there's an alternative method of using these kind of multiple if statements and chaining them. That is called a nested if structure. This is best suited when you are dealing with a multi-way decision scenario, such as the one you can see in this example here. So let's try to extend the program that we have written in the previous slides. So there's a student and we are just getting this grade of the student, and based on the grade of the student, we would like to convert it into a letter grade. So if the grade of the student is between 90 and 100, we would like to say you got an A instead of saying simply passed. But if the grade is less than 90 but bigger than 80, we would like to say B. Similarly, C, D, and F for these ranges that you can see in this example. So let's go to the code. Okay, again, I am starting with getting the grades from the keyboard, from the user. Then the simplest way, the way that we have learned so far, is just writing down a couple of if statements. If the grade is bigger than or equal to 90, as well as the grade is less than or equal to 100, I'm gonna say you got an A. Else, if grade is greater than or equal to 80 and grade is less than 90, then simply you got a B. Else, in the else clause of this second if, I will opening up a third if statement, which is gonna be extremely simple, extremely similar, only the ranges will be different. And similarly, there's gonna be a code by saying you got a C, one more for the D, which is gonna be again very, very similar. And finally, I will have one more saying like if it is less than or equal to 60 or less than 60, and grade is greater than or equal to 0. If that is the case, he's gonna say you got an F. In the final else clause, I'm just gonna simply say this is an incorrect letter grade. This is an incorrect grade, because there can be a case that the grade is given as a number bigger than 100 or less than 0. So although this is a valid piece of code, this doesn't look very nice to look at, because now for every single if statement, I'm going inside the code. I'm adding one more level of indentation here. And as you can see, it is becoming difficult to read and difficult to look at. So C++ allows us to simply combine these else ifs into something called an else if. And then I can just delete the level of indentations and I can just combine the relevant guys next to each other. So the thing is, this is now becoming much more clearer to read, clearer to understand, and now who is where, who is the else of what, is gonna be much easier to follow. Although from a technical point of view, these two codes, the previous code and this particular code, is equivalent, this is a little bit more, how can I say, elegant? Perhaps a little bit more elegant. Note that in such a nested if structure, the last component should always be a simple else, not an else if, because you have to finish somewhere, right? So generally, the main advantage, the main allure of this nested if structure is the fact that you are not utilizing multiple levels of indentation. You're just managing everything with a single level of indentation, which increases the readability of code a lot. But this is not the only way, and I cannot say this is the correct way of writing such a multi-way decision system. The simply writing it down like the if else and then another if inside the else and then going on and on like the previous solution of this particular example is also a very, very valid answer. Before continuing with the second conditional statement in C++, the switch statement, let us solve one last problem regarding the if statement. So here this is a bit of a modeling problem. So we have to understand what the problem asks from us and try to see, do we need to reuse an if statement, how many of them we have to use, what kind of a comparisons do we need in this particular problem. Write a program that computes and displays the real roots of a quadratic equation whose coefficients, the a, b, and c, are taken from the user. So the a, b, and c will be the inputs of our program. The real roots are computed as the following equation. So the x1 is going to be minus b plus square root of delta divided by 2 times a, whereas the second root is going to be minus b minus square root of delta divided by 2 times a. What is the delta? Delta equals b to the power 2 minus 4 times a times c. This delta, which is also known as a discriminant, it can take a negative value, 0, or a positive value. When you compute the delta, if the delta turns out to be a negative number, this means that this quadratic equation does not have any real roots. On the other hand, if the delta's value is exactly 0, it means there is exactly a single root, because the square root of 0 is 0, so minus b plus 0 and minus 0 will be the same thing, therefore in that scenario there's going to be a single root. However, if the delta's value is a positive value, then it means there are 2 real roots. Okay, so there's going to be a coefficient, but I can just simply write it down as a double, I guess. Coefficient a, coefficient b, and similarly there's going to be a coefficient c. There's going to be a delta, which is again going to be a double, And there's gonna be a couple of roots, which can also be a non-integer value. Therefore, I will be using double variable types for these things too. So looking at the problem, the first thing that we have to do is just simply calculate the value of the delta. Because based on the delta's value, we have to choose one of the options available to us. So delta equals coefficient b times coefficient b minus 4 times coefficient a times coefficient c, obviously. Then, if delta is less than 0, then I don't have to calculate anything. I will be simply saying that there are no real roots of this equation. Simple as that. I mean, you can say like there are imaginary roots, but we are not focusing on the imaginary roots at this problem. Let's try to keep things a little bit more simpler. Else, so we now have two conditions. If the delta is exactly 0 or if delta is a positive number. So I would prefer to use a nested if structure here. Else if delta equals 0. So if delta is exactly 0, then I have to calculate the value of root 1, which is going to be minus 1 times coefficient b. I would like to put them inside the parentheses because there is the division here. I don't want to be confused about what is happening here, so I would prefer to be on the safe side. You can get away with not using the parentheses, but well, the parentheses never hurts. There is a single root whose value is simply root 1. And finally, there's going to be the else, which will cover the case where delta is a positive number. In that scenario, I will be saying something similar, this guy, but now minus 1 times coefficient b plus sqrt delta, square root of delta. So I'm going to use the sqrt function inside the CMP library, which is going to be provided inside the regular C++ compiler. And for the root 2, very similar equation. The only difference is going to be there's going to be a minus in front of the sqrt delta. And I'm going to say std quotes, there are two real roots as root 1 and root 2. Alright, let me run this code. Again, the code itself doesn't look very sophisticated, honestly. There is only, well, one nested if statement, if you want to call it one nested if statement, or if you can call it like there are two if statements. But here, what is asked, how many comparisons should I be using, is the important and vital part of this particular question. I think this one was x to the power 2 plus 4x plus 4. It should have a single root of minus 2, which is the case. Let us try another example. I am unsure if there are no real roots in this version. And if I try to find something like this, apparently there are two real roots here, some weird looking numbers, honestly speaking. In addition to the if statement, there's a second conditional statement in C++, which is a switch statement. This is basically doing the same thing with the multi-way conditional statement like the nested if structure. But I can say this is a little bit even more elegant, and if you are just checking a particular value with certain ranges or certain cases, then a switch statement is a better suit, a better match compared to a regular if statement. However, anything that can be done with switch can be easily done with if. Maybe a little bit more sophisticated looking, but from a functional point of view, it's gonna be exactly the same. The main advantage of the switch is to reduce the code size, but in certain scenarios. So let's look at this problem. Write a program that reads a month and prints the number of days in that month. I'm gonna completely ignore the leap year concept. where the February will have 29 days instead of 28 days, for the sake of simplicity. So I will be needing two variables, I guess. Month index will be my input, and as a result, number of days is gonna be my output. So getting the month index is gonna be done with the CIN. Let's look at how many cases that we will have here. The month index, first of all, can be an invalid value. A valid month index value is between 1 and 12, including the boundaries. So anything that is less than 1 or anything that is more than 12 is gonna be an illegal month index. So if month index is less than 1 or month index is greater than 12, I'm gonna simply say illegal month index. Else. So what's gonna be our second case? My second case is gonna be if the month index is 2. If it is February, there's gonna be 28 days. Else, if month index is 2, I'm gonna simply say there are 28 days. Then else. So we have 4 months, April, June, September, and November, having 30 days. The rest of the months have 31 days. So I'm gonna say else if month index is April, which is 4, or month index is June, 6, or month index is 9, or finally month index is 9. If month index is one of these numbers, we can simply say there are 30 days. And finally, else is the case of the months having 31 days. So this is the solution of this particular problem if we only use the if statements. So this is, again, as you can see, perfectly valid, perfectly fine. The problematic looking thing you might say is this part. Why I'm saying problematic? Because it seems like there are a lot of repetitions in terms of comparisons. We are just making a lot of very similar comparisons. So switch statement basically allows us an alternative way in these kind of questions, in these kind of problems. So let me try to solve this particular question using switch. Okay, I think the int number of days was completely useless in this scenario, so let me get rid of that guy. And I will simply comment this part out because, again, this is gonna be useful for the sake of comparison. So instead of just going all the way with the if else statement structure, I'm gonna say switch month index. And I'm gonna open and close a curly bracket couple. And then I'm gonna say case 2. Case 2 means if the value of the month index is 2, do this thing. What he's supposed to do, he's gonna say there are 28 days. And at the end, what you are supposed to say is additionally something called break. So here I'm just counting all the cases that month index value can take, and based on these cases, what kind of different actions should I be taking? So as you can see in the top part, I will have 4 cases. So this is one of these cases. And what about the other case? Case 4, the April case. So the April case is actually the same with the June case. So I will not say anything here. Instead, I will just go down one line and I'm gonna say case 6. Similarly, this is also the same with September, case 9. And again, this is gonna be the same with the 11th month, November case. What am I doing at the November case? Similar to this guy, but the only difference is that there are 30 days and then break. Alright. So this is a little bit maybe weird looking compared to the if, but then you might say like, okay, this is trying to explain to me what am I gonna do based on the specific values of the month index. because the month index 2 do this. Month index 4, 6, 9, and 11, any one of these things, just do this part of the code. Do I have any other cases? Of course I have any other cases. So what are those things? The months who have 31 days instead of 28 or 30. These are January, obviously, case 1, case 3, case 5, all the other cases, case 7, case 8, case 10, and finally case 12. If he's one of these cases, let me check, 1, 2, 3, 4, 5, 6, 7, I guess, I don't know if my calendar information is correct, this should be the correct piece of code. What am I gonna do here? I'm gonna simply say there are 31 days. But now there's something missing, which is an illegal month index. As you can see, there are tons of other values that the month index can take because it's an integer variable, and integer variables can have many values. Obviously, it's not gonna be a very smart idea to just write down every single case here. Instead, what I can say is default. Default means if the month index's value is anything other than the cases I've explicitly written here, do this. And what should I do? I will simply say illegal month index. Simple as that. Let me run this piece of code. This is from a functional point of view exactly like the one that I have written at the top. Nothing is different. You may see like this is a little bit clearer on some occasions, or it might look a little bit more complicated. It depends. Honestly, I think for an example like this one, switch case is a very better match. However, in other, I don't know, if you have less number of cases, then using an if-else-if kind of nested if structure might be more beneficial to you, might be more clearer to understand, clearer to read. Okay, one final problem of the switch. Write a program that takes 2 decimal numbers and 1 character from the user in the form of number 1, character, number 2. So this should be my input formats: a number, a character, and a second number. What we are trying to achieve here is to design a simple calculator over the classical arithmetic operations, the addition, subtraction, multiplication, and division. So if the character is any one of these 4 guys, your program should perform the corresponding operation and display the results. Otherwise, the program should give a warning message to the user saying like this is an illegal operation. I will have this first number, number 1, I will have the second number, number 2, and I will have a character representing the operation. Let us call that the operation. Then first, the number 1 will be given to me, followed by the operation, and finally number 2. Switch, but now I'm gonna switch over the operation. If the operation's value is plus within single quotation marks, because I'm now referring to a character, be careful here, then I will simply say std quote, well, number 1 plus number 2. If this is case minus, I will be saying std quote number 1 minus number 2. If this is the case of a multiplication star sign, then it's gonna be star. And finally, if it is the case of a division, then simply make an integer division. Let us just focus on the switch statement. Therefore, I will not be dealing with the real division, integer division complexity. The problem tells us that any other characters should be ignored, so default is gonna simply say invalid operator or something like that. Invalid operation, perhaps. Okay, 7 plus 8, 15, good. One other thing, 5 minus 6 minus 1, nice. 4% 0, invalid operation. And say 21 division 7, 3. That is fine. So this is another good usage of switch, I can say, because instead of writing down a couple of if statements, this is much more clearer and much more cleaner. Aside the two conditional statements, the if and the switch, C++ also have a special conditional operator, which is very similar to the if-else structure. So instead of the first example that we have solved using the if and else, if the student grade is greater than or equal to 60, you say passed, otherwise say you failed, you can use something like this with the conditional operator. So the student grade greater than or equal to 60, question mark, which is the conditional operator. And how does the conditional operator works? You just write down whatever you want to be done after the question mark, and then you put a colon, and then you write down what you want to be done if the comparison's value is false. This is generally tried to be done in order to reduce the number of lines in a particular program. But if the number of things that you are supposed to do in case of a true or false case are a lot, then conditional operator becomes a very, very messy thing. Therefore, generally, it is a little bit frowned upon, I can say. Using a regular if-else structure is generally preferred over the conditional operator. But as you can see, this is an alternative to the regular if-else structure and can be used as if the regular if-else structure. Alright, so in this video, we have covered the control statements in C++, namely the if statement and the switch statement. We also very briefly look at the conditional operator, which is very, very similar to the if statement. In the next part, we'll be looking at the repetition statements in C++, the while loop and the for loop. Thank you for watching and see you next time.